Okay, exercise 3.8, sums and differences of areas. Now, with this, in this exercise, you really need to sketch each function. And sometimes to find the area that you need to find, sometimes you're going to have to add two areas together, and sometimes you're going to have to subtract two areas from each other. Generally, you subtract when it's like this. If I want the area, let's say I've got y equals negative x squared, I don't know. No, what's wrong with me? A negative, oopsie, very messy. All right, let's say I've got this. I don't even know what that curve is, but let's say I've got top curve. Let's say I want this area here. That area. Below the top curve, but above the bottom curve. What you do is you do, and I'll call this curve 1, and I'll call this curve, oopsie. Curve 1 is the concave down one. Curve 2 is the concave up one. To find the area bound by those two curves, you'll need to know the x values. I'm going to call that x2, and this is x. So this is x sub 2. This is x sub 1. To find the area between those two curves, you would integrate, you always integrate top curve minus bottom curve. This is the area between two curves. Just no. So area between those two curves would be curve 1 minus area below curve 2. So for the area between two curves, so this is the area between two curves, you do the top curve, so the area will be the top curve minus the bottom curve. If you do it the other way round, what do you think you'll end up with? A? All right, my notes are very messy. So what do you think would happen if I get it the wrong way round? You just get a negative answer. So this is curve 2 down the bottom, the concave up one. Curve 1 is the concave down one. You've got to identify which curve is on top of the other one in the particular region of area that you're interested in. All right? I don't care about here which ones. So I don't look out here and say curve 2 is above curve 1 out here. I'm not interested in that section. I'm interested in this section with the shading. In that section with the shading, curve 1 is above curve 2. Does that make sense? All right, so the area between two curves is always area of the top curve, integral of the area of the top curve minus the integral of the area, minus the integral of the bottom curve. Okay? Now, but whenever you're doing area between two curves, you must find the point of intersection. How are you going to know which values to substitute in? So which value would I put first, the x2 or the x1? Yeah, x2 is the bigger value, x1 is the smaller one. So the integral, sorry, this is like really messy. You'd put in the x values. You'd put the bigger x value and then the smaller x value. You need the points of intersection for area between two curves. Sometimes you've got to solve simultaneously and find the points of intersection. So I'm going to do a question now. Okay, I'm going to do question 5. Okay, so I'm not going to get to finish this all now. Actually, I'm not going to get to really do much at all. I'll just go through this theory first, then I'll do examples later. So this is when you subtract areas. Area between two curves. So for the area between two curves, you will subtract, provided you can see one curve is above the other. Then there are other types. There are other types that look like this. You might see something like this. I'm going to call this x2, x1. Now, you've got to break this up into two separate pieces. You've sort of got to say, well, I've got this first area here, area 1, and I've got this area here, area 2. I'm going to call this one function of x, and I'm going to call this one g of x. They're two functions in x, two different functions in x. Okay? So, actually, I should do them in colour. So, here I've got g of x is the pink one. I've got... So if I want that shaded area, try and do them in different colours if you can. So I've got two different curves. This one's f of x, the other one's g of x. Okay, doesn't matter exactly what they are, okay? See this area 1 on the left-hand side, is it below the pink curve or is it just below the black curve? You get a piece of paper or something or a ruler, you blot out everything else that you don't want to see. If you look at that area, where is it below? The black curve. It's got nothing to do with the pink one. So that first area 1 in there is underneath the black curve. So your total area will be the area underneath function of x between which values? x1 and 0 plus, see, this is when we do sum of areas. So this area underneath is only underneath that first curve. This other area under here is underneath the pink curve. So plus the integral from x2 to 0 of g of x dx. Yes, thank you. It's 0 to x1 in the first one. Otherwise, what will happen? You get a negative value. 0's higher. So this is the theory behind this exercise. That when the area is enclosed between two curves, it's the top curve minus the bottom. But when the area is side by side sort of thing, you really need to look and say, look, this area is only below that curve, so do a normal integration there. And on the other side, this other bit of area, the pink one, is really only behind the g of x curve. It's got nothing to do with the fx curve. So you just do a normal integral underneath that other curve. Okay, so the questions that I will do will give you examples of those two, but the most important thing is to sketch them. You'll also have to find points of intersection. I will do a couple of examples, okay? Not sure exactly what time. Yep, you'll be doing the exercise. I'll just see which questions I want to do. Okay, this is continuation from today's lesson. Didn't get to finish that off in class. There is one other type of area that you might do. So, for example, you may be asked to find the following area. Instead of finding, say, the area beneath the curve, you might be asked to find that area up there. That area, say, bound with respect to the y-axis. But this may be a function, for example, that you cannot integrate with respect to the y-axis. So, for example, if this is a function that you can only integrate with respect to the x-axis, okay, then there is another way of finding this area up here. And the way of finding that area, so that shaded area, will be, now I'm going to call this value x1 and I'm going to call this value y1. So the shaded area will actually be the rectangle, the rectangular area. So the area of the whole rectangle. Take away, let's say this, I don't know if it's going to show up very well. Yep, take away this, I'll do it in blue actually. Take away this bluey green shaded area underneath. So take away the bluish, greenish, this colored area. So this bluish, greenish area. Okay, so that's another way you can get this shaded area. Now, I will do questions like that for you in the exercise, but I'm just giving you, this really is the third type of question that you could come across, where You may think you need to integrate with respect to the y-axis, but sometimes you will not be able to integrate that type of function, okay? So what you would do is you'd find the area of the whole rectangle and then take away the area of this bluey-green section down there, okay? So therefore, this would be, the rectangular area would just be the value of x1, whatever that is, times y1, minus the blue-green area would be the integral, I'll call this function of x, okay? It would be the integral of the function of x from the values of x1 and 0 dx, okay? So that is the third type of question that you could get. Okay, I'm now going to do some examples from exercise 3.7. First thing I'm looking at is question 1. Okay, here is the first question. Question 1 from, sorry, I think it's exercise 3.8 actually. So find the area bounded by the line y equals 1 and the curve y equals x squared. As I said, you do need to do a quick sketch. So we've got, I'm going to draw it quite large actually. So let's say this is the line y equals 1. And this is the curve y equals x squared. And we know that when x is 1, y is 1. And when x is negative 1, y is also 1. So if we want the area bounded by this line and this curve, then it's actually this area up here that I want. Okay? Now, there are two ways in which you can do this question. Two ways. What I'm going to do, I'm going to take the approach of, like if I decide to integrate with respect to the y-axis, then I need to change this function. Instead of being y equals x squared, I have to make x the subject of the formula and make it square root both sides and get x is the square root of y and then integrate between 0 and 1. That is one way of doing it, and I will do it. I will start doing it that way, and then I'm also going to show you another way where you actually find the area of the rectangle minus these other areas. So two ways of doing this. You can see here that the area actually is bound by the y-axis. So first I have to sketch it, okay? So this is the line y equals 1. Be careful here. This is not the y-axis. This is the y-axis down here, and this is the line y equals 1. Okay, so a few different approaches that we can take. Okay, now actually I'll do the other way first. What I'm going to do is the rectangle first. So what I'm going to do, sorry, I know I said I'd do it the other way, but I've changed my mind. So what I'm going to do, I'm going to do the area of the rectangle first minus the blue shaded areas. Now look, this curve is symmetrical, okay? So I don't have to do this shaded area and work out this one because I know that they're the same. Okay, what I could also do is just this rectangle here, take away this little blue region, get an answer for that, and double it. Like there's many, many different ways that you can do it. Okay, so what I think I will do, I'll do this whole rectangle first. So the shaded area, the black shaded area, so the area that you want is going to be the rectangular area. So the rectangle minus, now I need to get rid of this blue area here. Take this away and find this area too here. Now I know that the area or the integral, this area here from 1 to 0 is the same as the area from 0 to negative 1. So I'm going to be taking away two lots of the integral from 1 to 0 of my function. This graph happens to be y equals x squared, so it's x squared dx. Okay, now hopefully you will see that. So it's my rectangular area. So rectangular area. Now the rectangular area is from negative 1 to 1, so that's 2 units across and 1 unit up. So it's 2 times 1, so that gives me the area of that whole rectangle, minus, remember, 2 lots of this little blue area here, which is the integral under the curve y equals x squared from 1 to 0. So minus 2 lots of this integral. Now when you integrate x squared, you get x cubed on 3, all between 1 and 0. Okay, so I've got 2 times 1 is 2, take away, remember, this here is this blue area. okay? And the other bit is your 2 by 1 rectangle, okay? So 2 minus 2 times, now we need to do our substitution here, and it will be 1 cubed, which is 1 over 3, so it's a third minus 0. So it's 2 minus 2 times a third is 2/3, so it's 2 minus 2/3, which is 1 1/3 units squared. Now that's one way to do this question. There is another way of doing it, okay? And I'm going to do that here. So the other way of doing the question is just draw it again, okay? I'll just do it down here again. And we want this area here, this is 1. This is the curve y equals x squared, and this is the y-axis, and this is the x-axis, and I'm just going to shade this bit here, but we do want both, okay? So that shaded area is an area under the curve with respect to the y-axis. So the other way of doing it is if I want to integrate with respect to the y-axis, I cannot use y equals x squared. What I've got to do is change the way it looks, so square rooting both sides, and I will get x is plus or minus the square root of y. Now one of these sides is x is plus square root y, and the other one x is minus square root y. So I'm just going to look at the first quadrant only, so this bit here, first quadrant, it will be x is the positive square root of y. Now I'm just going to work out that area. So the area in quadrant 1 is the integral between the y values of 1 and 0 of the square root of y dy, which is y to the half, remember, so it's the integral between 1 and 0 of y to the half dy. Now we know that this area, I'll do that in a minute about that area. Let's just work this out, and y to the half, you've got to add 1 to the power, you get y to the 3 on 2 over 3 on 2, and we need to substitute in the values of 1 and 0. Now, and then we get, and doing that substitution, sorry, before I do that, I get 2/3 y to the power of 3 on 2 is the square root of y cubed, doing the substitution of 1 and 0, and I get 2/3 times 1, square root of 1 is 1 cubed, minus 2/3 times 0, which is just 2/3, okay? Now, that is just the area in quadrant 1. We'll also notice that the area in quadrant 2 equals the area in quadrant 1 because the graph y equals x squared is an even function and thus is symmetrical about the y-axis. So therefore, your total area that you need will be 2 times your answer from here, 2 times 2/3, which is 4 over 3, which is 1 1/3 units squared. Now, that is the same as what we got up there when I did it previously. Okay, 1 1/3 units squared. Doing it this method, it's also 1 1/3 units squared. Look, I would prefer the first method. It does not involve rearranging the equation as we've done here. Okay, so I would definitely use the first method. With the first method, you could have just worked out this area in quadrant 1 as well, just doing the 1 by 1 rectangle, subtracting that area, and then multiplying by 2 at the end, or you could have done it like this, okay, the large rectangle minus 2 times those areas as well. So just showing you 2 ways of doing that question. I'm going to go to question 3 now. Question, find the area enclosed by the curve y equals x squared and the line y equals x. Again, you must sketch it. So we know y equals x squared is a concave up parabola, vertex 0, 0 at the origin. Just got to be very careful sketching this, okay? And the line y equals x also, so we know that, for example, with y equals x squared, when x is 1, y is 1, okay? The other thing is when x is a half, y is a quarter. But for the line y equals x, when x is 1, y is 1. When x is 0, y is 0. Same with the other curve. But when x is a half, y is a half. So it sits above. Actually, my parabola should be a bit lower. Okay, so I'm just going to fix that up there. Equals x squared like that. And as I said, for example, when x is half, y would only be a quarter. But with the line y equals x, it's a straight line, and it will actually lie, it will be sitting above the line y equals x squared, or above the graph, not the line, above the curve y equals x squared for only this region here, okay? Once x is greater than 1, then the parabola is higher or sits above the straight line. So if I continue that straight line in blue, but notice my parabola's up here, the parabola's y value will always be greater than the straight line's y value after x is 1. So what I was saying before, earlier on in the video, is that you must find the points of intersection between your two curves. And they are when x is 1 here and when x is 0. So therefore, to find the area enclosed by these two curves, it is top curve minus bottom curve. And in this case, see, the area under the top curve would give me this big triangle here. And the area under the parabola would give me down there. So if I do triangle minus that area under there, I'm left with that blue shaded area. So that's why we do it that way. So the area will be area beneath the line. So it's the integral of the line. Now the line has equation y equals x, so it's the integral of x dx between the values of 1 and 0 minus the integral between the values of 1 and 0 of x squared dx. Now I do not have to write it as two separate integrals. I can say, well, it's the integral between 1 and 0 of x minus x squared dx. Okay, putting that in brackets. So I can actually do those two together. Okay, the important thing is that we know that they intersect at 0, x is 0 and x is 1. The other important thing is that you know which curve lies above which curve. So the straight line lies above the parabola. So you must do x minus x squared. Okay, now to integrate, we get x squared over 2 minus x cubed over 3 between the values of 1 and 0, which gives us a half minus a third. Take away 0 minus 0. Okay, and we get a half minus a third is 1/6. Okay, because it's 3/6 minus 2/6. Yes, it's 1/6 units squared. And that is question 3. 7. Again, starting off with a sketch. Find the area enclosed between the curves y equals x minus 1 squared and y equals x plus 1 squared. Okay. 7. Sorry, I was recording, but not recording, so I've already started this. So find the area enclosed between the curves y equals x minus 1 squared, y equals x plus 1 squared, and the x-axis. It actually doesn't say in the x-axis in your textbook, but I think it is meant to say it. So first thing you do is sketch the graphs. First one, y equals x minus 1 squared is the curve y equals x squared shifted 1 unit to the right, because we say what makes this in here 0. X minus 1 to be 0 would be x is 1, so it's shifted over there. So the blue curve is the parabola y equals x minus 1 squared. Also notice when x is 0, y is 1. So you really need that point as well. That's really important. And when x is 1, y is 0. Now this curve over here is the curve y equals x squared shifted 1 unit to the left, because negative 1 plus 1 gives me 0. Again, when x is negative 1, y is 0, and when x is 0, y is 1. So I've drawn the two curves, and you need the area enclosed by those two curves and the x-axis, and it would be this shaded area down here. Notice I've shaded it in two colours. I've got a black shaded area, and that is only beneath the curve y equals x plus 1 squared. And I've got this blue shaded area here, because it actually only lies below the curve y equals x minus 1 squared. And so therefore the area will be the sum of those two areas. So it is the integral beneath the black curve, which is beneath x plus 1 squared dx, from the values of 0 and negative 1, plus the area, the blue area. Now the other thing is, those two areas are actually going to be the same, but you can still just do it like this. So the other integral is from 1 to 0 of x minus 1 squared dx. Okay, now a few different ways you can do this. You can expand this, and expand this, collect like terms and do one integration. Actually, no, don't do that, because you've got different integral values. So no, ignore what I just said. Don't do that because the integral values are different. So just do them separately. Sorry, there are two ways you can do it. You can expand this and go x squared plus 2x plus 1, and then you can substitute, but I probably wouldn't even do that, actually. It might seem like an easier way, but it'll be more complicated when you do the substituting. You'll have to substitute into more things. So we're just going to integrate as normal. So this is x plus 1 cubed over 3. And now this is of the format ax plus b to the power of n. So it's just x plus 1 cubed over 3 times the coefficient of x here is 1. And we are substituting the values of 0 and negative 1. Plus for this one, it's x minus 1 cubed over 3, increasing each power by 1, times the coefficient of the x, which is 1 again. This time we're substituting in the values of 1 and 0. So let's do our substitutions. X is 0, you get 1 cubed, which is 1 on 3, minus, substituting in negative 1 plus 1 is 0, so you get 0 cubed is 0 on 3 is 0, plus my other area, substituting in 1, you get 1 minus 1 is 0, so 0 cubed is 0 over 3 is 0, minus, substituting in 0, you get 0 minus 1 is negative 1 cubed is negative 1 over 3. Remember to put it over the 3. So I've got a third plus, we know that these two areas are the same size, so this is why this is minus negative a third becomes plus a third. So the area is a third plus a third, which is 2/3 units squared. Okay, and I think that's the best way to do that question. Okay, we'll go on to another question now. Question 9 from exercise 3.8. Find the area enclosed between the curve y equals x cubed, the x-axis, and the line y equals negative 3x plus 4. Okay, what I'm going to do first, I'm going to sketch that line. So when x is 0, y is positive 4. Okay, let's say when x is, say, 1, y is negative 3 times 1 is negative 3 plus 4 is 1. So it looks like this curve looks like this. Okay, now that's enough points to sketch that. But it's very, very important that we know here that we've got the point 1, 1 and that we've got the 0, 4 as well. Okay, now that's the line y equals minus 3x plus 4. The other thing that we're going to sketch is the curve y equals x cubed. So with y equals x cubed, when x is 0, y is 0. We know when x is 1, y is 1. When x is 2, y is 8, all the way up there, but we know that the curve looks like this, and it comes down like this. So this is y equals x cubed. Now, with this question, we want, just be very careful, we want the area enclosed between that curve, now I'm between that curve, the x-axis, and this line y equals minus 3x. So you actually want this little area in here. All of that. Now, I'm just going to put a line down the middle of that area. See, I'm actually going to have to find out what this value here is as well. So I actually need this area here. And the reason I'm shading that in black is it appears to be below the line. And I also need this area here in blue. Okay? So that gives me the area enclosed between the curve, the x-axis, and the line. Problem is, I know the bounds of like the x values to substitute for the curve y equals x cubed when I integrate beneath that, but I do not know this x value here. So I need to find that out. So when y is 0 for this line, y equals negative 3x plus 4, I need to put that in sub y equals 0 into that. And I will get that 3x is 4 or that x is 4/3. Okay? So therefore this here is the point 4 over 3. So therefore my area is again a sum of areas. It's made up of two areas that are side by side. It is not one curve below the other one. You would do one curve below the other if you wanted the area enclosed by the curve, the y-axis, and the line. So if you wanted the area enclosed by the curve y equals x cubed, the y-axis and the line y equals minus 3x plus 4, you would do the area between the two curves like that. But it's not asking you for that. It's asking for the area between the curve and the x-axis and the line. So it's really important that you read it very, very carefully. Okay, so again, this is a sum of two areas. First one, it's the area beneath the curve y equals x cubed between the values of 1 and 0 plus the area beneath the line y equals minus 3x plus 4 between the values of 4 on 3 and 1. Now notice that the integrals are from different x values, so you cannot go combining those two equations. They must stay separate. So just doing each integration, we get x 4 on 4 between the values of 1 and 0, plus the other one is minus 3x squared on 2 plus 4x, and that substitution there is the values 4 on 3 and 1. And doing that substitution now, we will get a quarter minus 0 plus, now we're substituting in 4 on 3, so it's negative 3 times, so it's negative 3 over 2 times 4 on 3 squared plus 4 times 4 on 3, you might want to do this on the calculator, take away, substituting in 1, you get minus 3 on 2 plus 4. So it's a quarter plus, you get some cancelling out here. See, this is 16 over 9 times negative 3 on 2. You'll get some cancelling, and it will be, you'll get 8 over 3, so you get minus 8 over 3 plus 16 over 3 there. Just you want to check that on your calculator. Take away, so we've got minus 1.5 plus 4 is 2.5. I think. Pretty sure it is. Okay? Sorry, I'm off screen. So look, you can do that on your calculator. I'm just doing it in my head, really hoping I'm not making any mistakes, okay? And so I'm getting a quarter. Now 16 over 3 minus 8 over 3 is 8 over 3, which is plus 2 2/3 minus 2.5. And you can get your calculator out to work that one out. Get 5/12 units squared as an exact answer. I think the answer in the back is rounded, and I think they get 0.42 rounded to 2 decimal places units squared. But I would leave it as the exact answer as 5/12 units squared unless you're asked otherwise. Okay, that'll be the end of the examples for today. If you could now just do, you can see that I've done some questions. I think I did questions, I just looked there, I've done questions 1, 3, 7 and 9 so far from exercise 3.8. If you could please do exercise 3.8, do the questions that I didn't do. So please do question 2, 3, 4. Did I do 5? I think I did. No, I didn't. 2. Actually, if you can do questions 2, 4, 5, 6, and 8. Okay, so do question 2, 4, 5, 6, and 8. I'll just show you that. So exercise 3.8, please do question 2, 4, 5, 6, and 8. Thank you. We'll do the rest tomorrow in class.